Greetings, Earthlings. Today we're going to dig down on this problem of why this Tandy Color Computer 2 is not working. And so I have brought out the heavy artillery, the logic analyzer. If I didn't have a logic analyzer, I would probably try replacing the CPU chip as the next step, just as a guess, but I don't want to do that if I don't have to, if that's not the problem, because it's soldered in, and that would involve desoldering it and adding a socket and stuff. So got the logic analyzer hooked up. And by the way, this model of the HP1631D does have a 2-channel oscilloscope built into it. It's not the world's greatest oscilloscope, as I've noted previously, but probably all of the stuff that I've done up until this point, if this was all you had, you could have used the oscilloscope in here instead of that fancy one I used, and then you'd be moving on to the logic analyzer. And as I mentioned in the last video, we really need more than 16 inputs. So I've got 16 data lines. I've got the read-write signal from the processor, and I've got the data bits, 8 data bits. So we can look at what it's doing. Now, in terms of looking at what it's doing, I did find out there on the web something called Color Basic Unraveled. Somebody has gone and disassembled the code in the ROMs, and so we can see what it's supposed to be doing. And so it should start at location A027. When you start up, when you reset a 6809, it reads location FFFE, and that has the starting address in it, and that's supposed to be A027. So I'm going to go straight to A027 and not do FFFE, because what happens with FFFE is that gets put on the bus for a long time, for like as long as you're holding the reset button down or whatever. So we're going to do a trace. We're going to do a single trace. Start the trace when address is, what did I say? A0, no. A027. A027, okay? And we'll see if it gets that far. So we'll run that, and we'll power on. And by golly, it does. Okay. So we go through A027, A028, and so on and so forth. How far does it get? I wish I knew an easier way than scrolling through this. There probably is one, but, you know, it would require reading the manual to figure out what it is. I see it's in a loop at A056 to A059. 0 out SAM control register bit is what that says. Okay, branching not none. Okay. And then we should jump to, let's see. We should jump to A0EE, it looks like, at some point. Yeah, oh, A00E. There it is. A00E. Yeah. Okay. That'll set the stack. Address. Enable that 63.5 microsecond interrupt that we weren't seeing interrupting. Oh well. I don't know what's up with that. Okay, and then it goes to A079. Okay, cold start. And here it's in a loop, clearing the first 1K of RAM. So that's going to finish off, since this only has, I think, 1,024 data points. That's going to finish off what's in here. So let us see if it gets out of that. And that would get us to A07D is where it exits that loop. A07D, run. Already it's got there. What? I didn't even reset it. Why is going on? Well, it's getting to A070. That much we know. We'll see. Yeah, now it's okay. Waiting for state trigger. Press reset. Boom. Okay, there. A07D. That does a JSR to A928. And then it should come back from there. That says clear screen. Okay, A9, and we can see it got there, A928. And it should come back to A080. Well, again, I'm just going to set a trap on that because I don't know how far down it is in there. But let's see if we get to 8. No. A080. Okay. That is the return from the clear screen interrupt. Run. I don't get this. Waiting. This is weird because it hit the trap first time. Well, okay, it does it sometimes. Okay, sometimes it comes back from clearing the screen. Okay, there's a data point. Sometimes it comes back from clearing the screen. Okay, here's a case. Well, no. Okay, there. I just reset it, and it did not get to A080. So, and I don't know. Yeah, now it's consistently not getting there. Okay, so let's do this. Let's go. That was a JSR to A928. A928 is the clear screen. And the return from that is A936. So I just want to see if it gets there and what it does if it gets there. A9, oh, stop. A936, okay. Well, it did get there. Okay. And that's showing a return from subroutine. That's the 3.9. So then it will, see, this is a prefetch. And then this is popping the stack. And 6060, it looks like the address, only that's not the address that it put on there. 60 is suspiciously the value that we were storing into the first, into the screen memory. And, but then you see it goes to E0C0, which I don't even think is valid address. Okay. So the stack appears trashed. Okay, just by way of checking, what I've done is I've stopped it at A07D, which is, not stopped it, but I've captured the trace, which is the JSR. And we can see here the JSR to A928. And it's pushing onto the stack in the locations 03D6 and 03D5. The return address A080. Okay. Then we go back to where it's trying to return A936. And we see the RTS 39, and we see it reading from 03D5 and 03D6, which were D5 had A0 and D6 had 80, and we get 60 in both cases. Yeah. All right, user error. I had the clock sense wrong on the previous traces, and so I was not getting valid data for the data lines. Address and read write were fine, but I was clocking on the leading edge, the rising edge of the E clock, and I need to go on the falling edge because the leading edge just happens too soon after the address is put out there for the data to make it back through to the processor. So with that corrected, what we see now is, and I've already run this, so at A936, okay, so this is the return from that clear screen function. That's the return from subroutine opcode right there, 39, and it's popping the stack here, E0C0. Now, what we pushed on the stack was A0 and 80. And if you look at the difference there, it's the same bit. Okay? If you have 1248 bit, in the high nibble, okay, the 4 bit is stuck on, it appears. Okay, so that kind of does implicate one of the RAM chips. It didn't show up obvious, there was nothing obvious when I probed it with the oscilloscope, probably because it's doing reads and writes and stuff, and so it would have been hard to notice that it was stuck on when you read it. That's my guess. So now I just have to figure out which one of these chips is that bit. I know this was the lowest bit here, so I don't know how these chips are laid out, but find out which one of these is that bit, and I'll replace it, and we'll see if that doesn't just solve this problem and lead us to possibly the next problem. If there's more than one, we don't know at this point. All right, I determined that this chip was the one, and I hold that up so you can see it. That chip right there, okay, was the responsible for that bit. So I'm going to go ahead. You can see the logic analyzer is gone. I've got the TV back. I'm just gonna go ahead and try it and see if that didn't fix the problem. And expecting the best, I've plugged the keyboard back in here. So let's see what happens. Okay. Power that on. Okay, the TV has to be plugged in. It is. It is plugged in. Okay, good. And then this has to be turned on. There's our green screen. Oh, look at that! Extended Color Basic 1.1. Under license from some evil company in Seattle. Okay. It seems to be responding. Let's do the standard test. Print. We would do a hello world. Hello Rangoon. 20. Go to 10. Run. Yeah! It's fixed. Okay. So, what have we learned? That sometimes an oscilloscope is not sufficient. It's good to have a logic analyzer. And when dealing with older stuff like this, well, anything microprocessor based, you need more than 8 or 16 channels. You know, if you're just doing serial stuff, then you can get away with 8 or 16. But when you have 16 address lines and 8 data lines and, you know, other stuff, you really need a decent logic analyzer. However, you don't need infinite memory. Okay, that thing only captured 1024 things at a time. And so it took a couple of tests, you know, to home in on the problem. We couldn't just set it up once and capture like 2 million data points and then scroll through them. We had to say, is it getting here? Yes. Okay. If it gets there, does it get out of there? Yes. Okay. No. Whatever. Yeah. So that's where we are. Let us see. Remember this? The cartridge. Let's see if it'll run that. Now, when I say run that, to run it properly requires a joystick, and I don't have a joystick, but look at that. Color baseball. We should be getting sound as well at some point. Let's see, I think I can get it into demo mode. Here. There we go. We've got sound. Cheers. Raucous cheering. Whoops. And the catcher throws the ball out into center field. The pitcher goes after it and runs into the left field wall.